So this juice mix problem, there are some information given in a table that oftentimes gives you all the information that you need, but oftentimes it doesn't. There are always different problems have different amounts of information that you have to extract from the context of the problem and from the words in the word problem. So in this case, the goal is to create a drink mix of at least 500 gallons by mixing different amounts of drinks A, B, C, D, and E, and that's measured in gallons. So our decision is to decide how many gallons of each drink to put into the mix. So your book puts it in the solution below here. X1 is the number of gallons of drink A to put in the mix, X2 number of gallons of drink B, X3 number of gallons of drink C, and so on. So the objective is to minimize cost. So cost is given in the right column. So just multiplying these cost values per gallon times the variable number of gallons and then adding those up give us the objective function that we see here, 1.5x1 plus 0.75x2 plus 2x3 plus 1.75x4 plus 0.25x5. Again, since we're multiplying numbers that come with dollars per gallon times variables that are measured in gallons, the resulting number is dollars. Now the constraints we have are, there's quite a few. First, we have to actually make 500 gallons, at least 500 gallons. So the sum of all the gallons of each type of juice, x1 plus x2 plus x3 plus x4, has to be at least 500 gallons. Each drink has only a limited supply given by the supply gallon column. So each of those variables has to be less than or equal to each of those numbers. And that's why we see x1 less than or equal to 200, x2 less than or equal to 400, x3 less than or equal to 100, and x4 less than or equal to 50, and x5 less than or equal to 800. Again, of course, all these variables have to be non-negative. You can't produce or mix in a negative amount of gallons. And then we have the constraints on the types of juice that have to be in the mix at certain proportions. So we need at least 20% of the entire juice mix to be orange juice. So how you would do this is you would take 0.4 x1 plus 0.05 x2 plus 1 times x3 plus 0 x4 plus 0 x5. That will be the amount of orange juice in the mix. That has to be greater than or equal to 20% of the mix, but 20% of 500 gallons is 100. However, what if we make more than 500 gallons? Well, then we have to account for that. So what we're really going to do is we're going to say 0.4x1 plus 0.05x2 plus 1x3 has to be greater than or equal to 0.2 times the total amount of juice, which is x1 plus x2 plus x3 plus x4 plus x5. If you then simplify those together, you're going to get one of these top three constraints here. Let you work out the algebra to figure out which one. And then you do the same thing for the grapefruit. 0.4x1 plus 0.1x2 plus x4 has to be greater than or equal to 0.1 times the total x1 plus x2 plus x3 plus x4 plus x5. That gives you another one of these top three constraints. And then you do the same thing for cranberry juice, except this is just going to be 0.2x2. It has to be greater than or equal to 0.05, 5% of the total amount of mix made, which is again x1 plus x2 plus x3 plus x4 plus x5. So these top three constraints are simplified versions of the constraints that are for the orange juice, grapefruit juice, and cranberry juice requirements. The fourth constraint is just the fact that we need to make at least 500 gallons, and the other constraints are just the limitations on each resource available. Each drink has only so much supply, so we can't go beyond that.